Okay, the clock has started, so I'm good to go. Is that right? Okay, terrific. Okay, well, thank you very much for coming to my talk today. I'll tell you a little bit about my journey here and got here, but I did want to tell you one thing before I get started. I gave a talk, last time I gave a talk at a Postgres conference, it was at this particular conference. Postgres was actually the first version of this particular conference, and I gave a talk on PL Java. And about 15 minutes before this talk started, I had about 4 times the number of people here for this topic than I did for that topic during the entire talk. So thank you very much. I want to thank you. And having the big room, I was concerned about repeating that experience. Okay. So just to give folks a little sense of who I am, I've kind of been in the Postgres community working with a lot of the major contributors and players. Probably, I'm going to make a claim that I didn't realize till just this moment. I think more Postgres committers have worked for me than anybody else. So I don't know if that's I don't know if that's a particular claim to fame, but I was the vice president of professional services at Enterprise DB, later the vice president of engineering. I've been in the enterprise software world for, I don't know, 25 plus years, in the software world for 31 or 32. I'm old. And I've been working with Postgres for about 8 years. It's become a real passion for me. Some of the topics I'm going to talk about are a real source of passion for me. I'm the founder of the Boston Postgres Users Group, which is about 200 people. I've had responsibility over the course of my career for the operations of over 500 Postgres clusters and across many different institutions. So I've kind of been behind the scenes. Every now and then I get out from behind the desk and they let me do a talk. Currently, I am very excited. I am part of Second Quadrant, which is a company I've admired for a long time, and I'm very proud to be a part of that. I am the general manager for North America. And what that means to me is there's 2 things I take care of. I take care of the people who work for Second Quadrant, and I take care of the customers, some of whom are in this room, who employ our services around support, training, and consulting. And I try to contribute as much as I can to moving the Postgres project forward in every way forward. Okay, so that's a bit about me. A bit about Second Quadrant, and I know I'm not right on the topic yet, but it's important. The background of how we got here is going to be relevant to some of the things I'm going to say on this topic. So we are a Postgres support company, but we were really founded in this manner, and I love the story. We had our founder, Simon Riggs, was told at one of his previous employments to find a database for replacing Oracle, the best solution for replacing Oracle. And somebody quickly whispered in his ear, well, it should be SQL Server. That's the answer he was told to come up with. But Simon, being Simon, did a thorough researching job, and he decided that Postgres was the right database, and he implemented a lot of the enterprise features and became very passionate and very engaged about Postgres, and contributed features like backup and restore, point-in-time recovery, streaming replication, a lot of the features that are very key to making enterprise ready and for dealing with things like high availability. And so we're a company, we're funded through the support of Postgres servers. That's our business. We have passion on 2 things. One is advancing the Postgres project, and the other is providing excellent support to our customers. Okay, so now getting into the topic that we're here to discuss. The term multi-master is a very overloaded term. It means a lot of different things to a lot of different people. And I'm going to talk a bit about how people get to conclusions. And you'll notice that some of the products that are around this particular conference don't refer to themselves as multi-master. Postgres BDR, bidirectional replication. All right. Citus, I was talking to Marco saying we use an MX architecture. We refer to it that way so people don't immediately jump to multi-master. And that's important because there's a lot of preconceived conclusions people have about what multi-master means. And I'm going to go through what some of those mean and how there's sort of these confusions about it. I'll tell an illustration about how this exploded into a room of debate right here at this conference during a lightning talk. So as I say, I'm going to talk a bit about what multi-master is. Then I want to talk about a particular variant of multi-master, and that is around loosely coupled replication-based multi-master and how it differences for other solutions. and the various implementation techniques of it. And I will be using BDR, Postgres BDR, as an illustration of how we've implemented things, but I'll talk a little bit about alternative approaches that I've seen in other products as well, none of which I will name. All right. So we are a sum total of our experiences. All right. This is that I've currently that people see things very differently depending on where they came from. In the keynote, a very interesting point of view came out that people are developing applications around Mongo. The young people are of this day and age, they're millennials, are developing applications around things like Mongo and Cassandra with key value stores. And they tend to think different about some of the problems we solve in the Postgres world, and our users and our customers solve with the sound practices of a relational database, and we'll talk about that. But similarly, most people, or many of the people who are coming to the Postgres world, and this has been my experience in the last 8 or 9 years, are coming from a very specific use case. And often that is Oracle. They're coming from Oracle. So it's kind of interesting. I saw that there were a variety of companies that we've seen. We have Microsoft here, we have VMware here, we have Amazon, we have Google, lots of companies represented, but nobody from Oracle is here because a lot of their users are coming and migrating to Postgres, and that happens. And the way they think about multi-master is based on a very particular solution. All right? It kind of looks like this. In fact, I haven't looked at the latest releases of it, and I'm trying to, but this is basically the Tom's view of Oracle RAC, and I'll tell you why I got very interested in this, to spend several days in somebody's house just talking about RAC, because I actually saw a lightning talk here where somebody from OmniTI, and I've forgotten the gentleman's name, got up and said, we need a RAC-like solution in Postgres. And it was funny, it was humorous, but I mean, it was very wild. I mean, people were, throwing stuffed dolls and things like that, and the room became very animated. And the people are very passionate about it. The people who come from this world, as I say, people are coming to Postgres, and when they hear the term multi-master, a lot of times, more often than not, this is the architecture that they are thinking of. This is, so to kind of state what this means, this is what you will call a shared nothing, or I'm sorry, a shared everything, little mistake, or a shared nothing architecture, where you have a number of nodes who are all capable of taking read and write transactions going to a shared storage device. And that has some advantages we'll talk about, but this is the mindset people are coming from, okay? When they think about that. So oftentimes, when people are coming to Postgres from the Oracle world and they hear the term multi-master or active-active, this is what they're thinking about. Now, what you'll see is I go through all of these particular approaches for what I'll call multi-master, active-active, whatever you want to say. All of them are optimized for one use case and have some benefits on another use case. So after that lightning talk, I went up to the gentleman who got up and said, well, I think we should have Oracle RAC and Postgres. And I said, so why did you say that? And I said, what is Oracle RAC about? And he said, well, it's a availability solution. It's not a scalability solution. Well, and then I've talked to many people since then, and it's the idea that if I want to apply a patch on one of these nodes, I can, without taking down the cluster remains active and things are good. If I want to do an upgrade on one of the nodes, I can do that. If one of the nodes fails, everything's good. So it's really optimized for availability. It's not optimized for scalability. I mean, you could look at that, and you can come up with various reasons why that is. But it's effectively, if you can scale, if you can manage to revisit parts of the data in the same node each time. So effectively, by partitioning the data, it becomes scalable, right? So I have some of the records on the node all the way to the left, other records on the node all the way to the right. but I wind up with a scalable thing. But that's hard, all right? Now, a couple of, oops. Okay, so just to kind of recap, all right, there's the availability is first in the solution, all right? You can be horizontally scalable if you can eliminate the chattiness between nodes. And this, again, this is after I exited the last many years, I've talked to many DBAs and developers, and this is where I've concluded. This is where I've concluded after many discussions with folks. People will say other things, and people have different passions about it. This is where I've come, okay? But there's this concept, there's this mind share. People sleep better at night because it is active-active. They don't sleep better, they think it scales. Now, the truth of the matter is, if I go back to, let's see if I can make this work. If I go back to this, the obvious thing people will say is, well, I see a single point of failure right down there at the bottom of your slide. Well, and that's where more debate comes in. Okay, well, everything in the disk is redundant. Will it fail, and that sort of thing. Okay, but another point of saying this around availability is in the modern world where natural disasters are happening. This is a solution that's very centered on a single data center. There are ways you can make it go to multiple data centers or fail over to another data center. But the expense at $48,000 a core in setting it up and getting it correct and getting the versions right, it's a very hard problem to have a multi-data center solution for something like this. And with all the natural disasters going on, we have, if you're in Houston, you're dealing with water, or Dallas, you're dealing with water, Puerto Rico. If you're in the Pacific Northwest, you're dealing with fires, all right? And the expectations around availability keep getting higher. You have to be thinking about natural disasters. So I would submit there are issues here around the shared storage, okay, and there's issues around the data center. So I wanted to talk a little bit. Okay, so that is the availability solution people are talking about. So let's talk a bit about sort of the stock Postgres availability solutions. And I realize that there are many of them, and there are many things to do. Postgres in and of itself does not have built-in high availability. It has features that enable high availability, such as streaming replication. Many of these things were developed and contributed by Second Quadrant. But Postgres ecosystem has lots of things for high availability. All right. So this is the standard thing. This is the standard master with a number of standbys. The master fails. Standby gets promoted, and the remaining two standbys follow the master. And this is, in this case, it's facilitated by Rep Manager. And that's what happens. It's something external to Postgres. But there are other ways of doing this, but this has been a very reliable and proven way for our customers. All right, so that's it. Now, a couple thoughts on that. So there is a moment, there's two things here. Would you compare this to the Oracle solution? There are two obvious things that are, maybe aren't wins. One is there's a promotion that has to take place. Okay, and there's a moment in time where nothing's available. The standby is promoted to the master, and that depending on who you listen, I've seen that Amazon say at times it's 30 seconds going across the country, and maybe 60 seconds. We've seen all sorts of measurements, but that feels roughly about right. There's a moment of impact there, and for most people that's okay, or a lot of people that's okay. The other thing is this is typically an asynchronous replication type solution. So there is some potential loss of transactions. Again, so you do a lot of ways to remedy that, keeping up, using synchronous replicas, but this is oftentimes what people encounter. So that's a little bit on the maybe comparing it to RAC's availability, but now comparing it to where it ranks and shines. It's much easier to handle a data center loss in this kind of configuration. So if you'll notice here, I have a master with a number of standbys in my US East data center. And then I have I have a standby in the West with 3 cascading replicas. In the case of my East failing, my West standby that was cast is now promoted to the master, and I effectively have the same solution. And that's something very robust and very, it's really graceful in the way that a combination of things like Postgres together with Rep Manager can handle something like this. So again, you make some trade-offs, and this is the thing where you find with all these solutions around multi-master, people come from a mindset about what it means, but you make trade-offs in the course of your discussion and your deployment. Okay, and a quote that, tell me, the quote Brad gave me as I was telling him a little bit about my presentation, which I really enjoyed. He says, I'm excited about the concept of multi-master getting into core, but I'm also very nervous because people come with all sorts of different expectations. They don't think they have to think about a whole new set of problems. And the truth is they do. They need to think through some of these, both in deployment and, as you'll see later, in application design. Did I capture your pretty much, or could give or take a little bit? Okay. All right. So before I get into, getting to the solution I'm here to talk about in a few minutes. Before I get into, there is another availability solution. I mentioned with Postgres, you see commonly deployed in Postgres is that it can do something similar to Rack, where you have active standby, and on the failure, the standby is promoted and they're running over a shared disk. The nice thing about this is there's one copy of the data, which some people like, but in the same sense, there's no transaction loss you might have with an asynchronous replica or the performance hit you might take with a synchronous replica. And I do want to kind of hit some other solutions. As I was talking to the architects from Citus, they were saying they were avoiding the concept of calling themselves multi-master. We, the developer or the delivery of Postgres XL, which is something we've contributed very, very heavily to and are very proud of, also don't reach out to it as a multi-master solution. And the reason is these are solutions that are centered around, well, I can't speak for others, this is why I don't do it. I can speak for other people's reasons. But these are solutions centered around scalability. And so many people come to the multi-master solution with the mindset of availability. All right, so now I get into what I really wanted to, so I told you that story so I could tell you this one. So one thing I spend a lot of time talking to customers about is Postgres PDR, and I'm going to refer to it as a loosely coupled multi-master replication system. And it's also has features around availability and scalability, but it's optimized for yet another problem that multi-master solves. Okay? So I have users who are in Tokyo, New York, and Barcelona in my particular example, and I want them to have a good experience with my database. All right, so what is the problem this solves where I have something like this, where I have replicas in these particular copies, or copies of the data in each of these locations? Well, I get the data closer to the user for better response time. And we talked about availability being important. We talked about scalability being important. Response time, if you have a mobile app and you want your 4-star rating, you better have good response time. And this is a solution. There are various other aspects of this too. And I've done this in the following order, where I've put in bold, get closer to the user for data time, but it also enables some other things too. One is the zero downtime failover. I don't have to go through the promotion process any longer if that's a real issue for me, where a standby, I don't need to wait for a standby to be promoted for a master. And I can get horizontal scale through geographic partitioning. And then finally, I'll talk more about this a little bit later, but one of the beauties of logical replication, one of the many beauties is you don't have to replicate all the data. And there may be just some subset of the data you want close to all the users, and you can determine that. So getting down to this, you see here that I have, in US East, I have something that's, I have an application server that's in the same data center as the database. My response time to this, getting the request to the database and back to the application server, 5 milliseconds. If I spread this across the country, and I have a data center in the US East and US West, it's 100 milliseconds. Now, that 100 milliseconds is not something measured from a benchmark. That is a best case scenario. That is the speed of light to go from one end of the country to the other end. Okay, so you figure that now you're going to have network latencies in there, you're going to have disk latencies in there, and all sorts of other things associated with it. And this becomes a problem. All right, so a few human factors. 100 milliseconds. If I see something takes under 100 milliseconds, I feel like it happened right away. All right, this is somebody at age 53 standing before you, and that sort of thing. At age 18, I don't know if that's still the case. But an acceptable wait period of time, well, people will wait for something, is maybe 2 to 5 seconds. And I say this is going down all the time as our users get younger, much closer to 2 seconds, maybe. And so these are things. How much budget can you give to the latency that comes with having to go across geographies consistently? And then after, say like 5 seconds, 10 seconds, then people start doing something else. They'll click on another tab in their browser. They'll go get coffee. And again, your application user experience starts to erode. And this is a real use case of one of our customers. They have users in Sydney. They have users in Europe. They have users in California. Okay, maybe they don't have users in South America, but they hope to someday. And they spend a lot of their time in the application is assembling the graphics. They cannot afford to give their database a big budget for response time. And this is effectively how they've deployed it. Looking at some other things, we've talked to carriers about BDR, cell phone carriers. I want to get the database as close to the user as possible. So I have nodes replicated all over the country. Maybe even a few more than this. I want the experience to be positive. When they do a write transaction, a read transaction, as fast as possible. Okay, I want as much time spent drawing the beautiful user interface that's up on the screen. Okay, it's accounting. Okay, for the clocks, I don't know. Okay, so we understand a little bit about the problem we're solving. So I want to talk about the design principles in coming up with a solution for this. Because again, these were these things. The second you go multi-master, back to Ben's original comment, the second you do that, you need to take on some understanding about your access patterns and a bit about the way the system works. Okay, tables need to have primary keys, and if that's not obvious to everybody, the idea is that a row, a tuple, the Tom Kincaid tuple could be updated both in California or in Massachusetts without the knowledge of the other update happening. So that's where we'll talk a bit about you need the ability to resolve conflicts, and you need the ability to replicate at each node. And how you go about doing that, it may appear obvious, but there's various approaches to doing it. All right, so let's talk about the primary key generation. All right, so I have a deployment where I have a customer in Sydney, a customer in New York, and a customer in Tokyo. All right, and I have users who are entering the customers in. This is an application. I have customers and orders, so we're all inserting into the same table, which is replicated in each of these locations. So that's what happens at time X. I insert the customer. In this case, they all have each of these databases does not know about the tuples on the other database, right? Okay, this is what's happened at time X. And then at time X plus Y, the data is replicated inside the customer table on all nodes. But the real thing is, at this time, those numbers in the left-hand column have to be unique. And so how do you do that? How do you ensure that without doing it? So there are many ways of doing it. The most common way that we think of in a single node database is you use a sequence. You let the database handle it. Next sequence, next value. But let's say that's not available to you in a situation like this. What would you do? What are your alternatives? One is you could use something that's application-based, where the primary key is some unique key with each user, where it's guaranteed to be unique. But that's hard. There's a lot of, if you have a many table application, making a unique key that you know about for each particular table is very hard. People, maybe you're constrained to the United States, maybe social security number will work, But then you've got to deal with user entry errors that wind up doing duplicate errors. So that's a little bit tricky. One thing you can do is have a ticketing service, all right, where you go to either your application server or your database goes and gets an ID from a ticket, and it ensures it all for you. But now you've introduced, there's a couple problems with that. One is there's still another level of complication, something else your deployment needs to worry about, but also something that increases your latency, right? So now I've done something where I'm generating a key, I go to an external server, it says give me next key. And then you could have something where the nodes communicate with each other and decide what the next key is. But again, that's a latency thing. Even if you distribute a batch of keys, okay? I want more keys. I want more primary keys. Okay, you get 2002 through 2015 for the next value in your global sequence. You have to do with it. Okay. And then finally, the thing that we've settled on over a period of time is a node-independent algorithm, that each particular node has a way of generating the keys. And this is something, as you get into an application, something you need to be aware of, and we'll talk a little bit about it. So the great thing about this is you can use native PostgreSQL types. So one thing I didn't mention on the previous slide was GUIDs. GUIDs are probabilistically never going to repeat but it's non-deterministic. It can happen, and people in the database world do not like things that can potentially cause corruption. But if we have Postgres native types, okay, and a single node, the pros are a single node can generate an ID without connecting to the other nodes. So some cons, the values will not be sequential, which is problematic for some applications. Okay, so this is one of those things, a trade-off you have to make when you go from a single node system to a globally distributed system, things you need to think about. And you have fewer values for the total sequence. And sometimes, depending if you're using, in the case where we're going to do this, what we do is we take the timestamp, the current timestamp on the machine. We take the node ID of the machine. We do a bitwise operation to get a unique number based on timestamp and node ID. And the value about this is it can be repeated. I'll talk about that in a moment. Things can be repeated. And then you use a local sequence value. Hence, you get a primary key that is unique across the cluster. And the nice thing about that can happen fast, and you can do that with minimal to no cluster communication. Okay, you will follow me on that. Okay, so let's talk about now how do I get the data between nodes? How do I get the data from New York? How do I get those values, those 3 customers that I've inserted into my database? How do I get them from Tokyo to New York, Sydney, et cetera? How do I handle that situation? One deployment I've seen, one application I've seen, is you send everything to a centralized server. The centralized server will do things like conflict handling or conflict resolution, which I'll talk about in a minute. And then it will publish things out to the other servers. So there are some, the way I've set this up, I've kind of set this up so that there's some obvious problems with this. The obvious problem being this is a potential latency issue, right? And we call this particular approach, the issue you encounter, write amplification. You're writing more times than you need to. So I write once on the local server, then on the centralized server, and then in the remote server, or remote servers, as you say. Oftentimes, this is done with triggers as well, and shadow tables and triggers. So you actually have a write to the main table, the trigger in the shadow table, and then the central server. And then from the central server over to the remote server. So there's a lot of writes. It is something where you wind up with a replicated data with things like that, but there is a potential issue here. The longer it takes, there's 2 things. One is the more out of sync each user is having in each location. And the other issue is the longer it takes, the greater opportunity there is for conflicts. So I've kind of outlined some of the negatives. On the positive side, you do have a central server where you can do a single point of monitoring and understand where each thing is in the replica and see how things are. So that's value. Not that you can't do that with other approaches. It's just simpler in this case. All right. So what we've done with our implementation, and this took some work, is we've developed a mesh. Every server is connected to every other server, has a relationship with has a one-to-one relationship with their server. And with BDR, what we do is it's not trigger-based, it's wall-based. So I look at the transaction that was written to the wall. I have it replayed. I ship it over to all the other nodes and have it replayed there. So no triggers, no opportunity for additional table bloat or traditional writes. And I asked Simon about this. Well, is the time? How do you make sure things stay in order? Well, the timestamp is actually put in the transaction, is put together with the transaction, so you can play them in order. So there is something you need to synchronize. It's best on all enterprise applications to synchronize the clocks, but it's important here. And so this is the mesh architecture. And the thing that's kind of nice about this is it's a lot. I should say, one of the things I really like about this is because it's logical replication. I can have different versions of Postgres on each particular node. All right. And so here is here's another. This is sort of like a futures type thing we envision going with second quarter. I could have nodes in each where I could have subsequent nodes or subsidiary nodes in each of my data centers. Okay, so I'm doing logical multi-master replication across these 4 data centers. And then I could have physical replicas off of each of the nodes, or I could have logical replicas off each of the nodes. And getting things a little bit more exciting, I could be replicating part of the data between the subsequent nodes, and then part of it to and from, I could be replicating it into the primary. Let's see if I can get this to work. Which is I'm not doing that anymore. Okay. So the idea being that I can have both logical and physical replication in each direction, and then various points of the data. There's a whole wide range of applications you can envision, and where we're taking things or we're thinking about things is the change hub. Is having a change hub for applications where changes are populated throughout the enterprise in this particular format. All right, so let's get to conflicts. So I'll take my friend Ben, who here's like that, where I've updated his salary to $200,000 in Tokyo at time T1. In New York, another HR user, updated his salary Ben's salary to $300,000. And this happened before the replication occurred across the wire. Okay, so this is why fast replication mesh architecture is important. The faster the replication can happen, the less likely you are to have to deal with things. But you do need to deal with these sort of things. Okay, so let's talk a little bit about that. Okay. So in most systems, including our system, the last update wins. Okay, so look at the update of time T. In this case, time T2 is greater than time T1. You can have many debates about that, but okay. At time T, so in this case, Ben wins. His last update of he now has a $300,000 salary. But that doesn't have to be the case. You can say that the first update wins. You can override the default handling. You can do it at particular table levels. But again, like you had to think about the global sequence ID, this is another thing you need to think about when deploying such an application. All right. Now, let me kind of elaborate on that. What kind of conflicts do you need to handle? This is an application design decision. If you have an insert-only application, this scenario never develops. If you have an insert-only application with global sequences for primary keys that are shared across the cluster, you have very few conflicts you need to deal with at all, if any. I could probably put my head together and think about some, but if you look at some of the documentation, they'll talk about all the various types. But you have very few conflicts to deal with at all. So you need to consider your deployment patterns and your access patterns. So going back to another way of dealing with something like this. What if I say that the only person who can change Ben's salary is Ben's manager? And then what if I say that Ben's manager is always connected, whenever he logs in, he always connects to a server in the server in New York. Unless it's down, then he goes to some other designated server. In that case, this never happens either, because Ben's salary is only updated in New York. So again, an application design pattern to deal with these particular things. There are things you need to think through in these kind of scenarios. All right, thinking a little bit at a larger system. Okay, so then you need to test for conflicts. So when you're choosing a system that's going to do these sort of things for you, you need to enable testing somehow. The way we've done it is we could set a replication delay. I'm going to run a stress test, a multi-user stress test with a replication delay of 30 minutes. I'm going to run it in my lab, and then I'm going to look at all the conflicts that were logged. If in some cases there may be, in the situation that I've described, maybe there'll be none if it's an insert-only application. But the fact is they'll be logged, and I'll see how they're handled, and I'll want to make sure they're handled appropriately. And then the other thing is, when you're thinking about this in an application like this, I want to think about my user experience. What is the data that I need to have replicated in all of these geographies, or all of these nodes? Think about that, and then you have less to replicate. You have less conflicts to handle. Your data moves faster. Everything's better if it's a smaller subset of the data. And again, these are design considerations. You go into this. And then there are situations where, okay, I'm going to need a global commit lock. Okay, I'm going to take a lock across the entire cluster when I do this. Currently, we do that for DDL. All right, so I want to add a column and do it across the entire cluster to a table, and I do that with a DDL lock. So do maintenance. And then again, you may design your application in such a way that DDL changes are very minimal. But again, you're trading that off. You're considering that for the benefit you're getting of getting your data close to the users, which can be substantial in the case of many different types of applications, particularly consumer-oriented applications. Just to kind of give one more example before I move on to some conclusions around some of these things. One thing I have seen this deployed is when you have, we've seen a Navy look at this, or a Navy look at a solution like this, where they have a large series of boats that are connected and disconnected, okay, where they're separated, but only a small subset of the data needs to be sent back to a hub where the Navy office. But they're able to make updates to their local database when they get connectivity back. The changes that they made are replicated back to the main office. So, some conclusions about multi-master replication and geographically distributed multi-master collection. It gets the data close to the user for better user experiences. It can enable additional nines of availability. Remember, because this really is an active solution, I don't have to go through the promotion process of one node being a master. Or the other thing is, one thing that I didn't mention in that situation where there's an automated promotion process or failover is you have the situation where you potentially have a false failover. All right. So the system detected because of some network connectivity issue that the master was down, so it failed over to the replica. If you have two active masters, you don't need to worry about that. You can allow for selective replication portions of the database. And then finally, I want to say that Second Quadrant has been developing BDR for many years and had the vision for many years. And we've been contributing many portions of it to Postgres as time allows. And eventually we'll contribute all of it to Postgres. But when it's there, you will have these, as my friend Ben points out, you'll have these additional things. You'll have these additional opportunities, but you'll have these additional things to think about in terms of your application design. All right, so we are, just to kind of talk a bit about once again who we are the Postgres support company, and Second Quadrant Postgres BDR is available now. You want to come talk to me about it, I will be around after this talk. Simon is here as well, and you can come by the booth, and I'd love to have more discussion with you about your use cases. I talked about some of the use cases I've seen, but every time I talk about that, people tell me about use cases I haven't seen. Okay, so with that, I have 10 minutes. We have 10 minutes. If people have any questions about this or any comments or thoughts, I can take them now. So. Yes, question? Do we have any issues using transactions across the cluster? So it is, because of that, it's an eventually consistent architecture. So you do have situations where we replicate an entire transaction or not across the architecture, and we replicate them in order. But transactions are not uniformly committed across the entire cluster. So you think about the CAP theorem, right? Consistency, availability, and partition tolerance. We are about availability and partition tolerance, and consistency is where the thing that you have eventual consistency in this scenario. Other questions? No? CJ?
When you have a node fail, what does recovery look like to rebuild that node?
If you have a node fail, what does recovery look like? So I'll tell you now, to give you the future. Different systems have this, but recovery would mean you would clone. You would bring in a new node, have it rejoin the cluster, and have it effectively clone it. The data come flowing back in. You could in future releases, you can have you'll have something where you'll have a physical. That you could have a physical standby, just take over for the node, or the primary node. So if my New York node failed, my New York node standby would just take over and join the cluster. And then you will be supporting things like using barman for backing up a cluster or a node in the cluster. But that's present. That's not present. That's futures. Yeah. Second question.
Yeah. So I guess a follow up to that then, if things need to resync from the other nodes, how does that sync occur? Can you explicitly say I want to sync from just this node that might not flood intercycle?
Right. Okay. So the question is, if one of my nodes fails and I need to resync from another node in the cluster, can I specify which node I synchronize from? I don't know for certain. I believe the answer is yes. Simon, do you know the answer to that?
The thing is, it's connected as a mesh, so you can't, all the changes flow directly from the node that makes the change to all other nodes. So if you were to specify, I don't want to receive some changes, you'd be missing some data. It's not like you don't get sent, if you've got 4 nodes, you don't get sent 3 copies of every single change. You just get sent each copy once.
So when I stand up in that mesh, I'm going to pull from all of those nodes simultaneously.
Yes.
While that builds.
4 reasons on waiters. Yeah. So we're not passing the data in a sort of cascading fashion around. That's a future possible architecture, but it's going to get really complex type of architecture. So that's 2 or 3 years away before we want to attempt what it's like to have a non-mesh.
Oh, I got you.
How robust in the face of extreme latency is it? I've dealt with this problem set with things in like Hong Kong and Amsterdam and locally. And networking to those places is not always reliable, so latency can be
Yeah.
hours. I mean, it's at best 280 milliseconds, but it might be
Yeah.
miles.
Yeah. So with extreme latency, it's designed for the disconnected user case, right? So that people can be dispersed and have that sort of thing. Where it's where it could be disconnected for a while. Or where it's partly if there's a lot of transactions during that time, a lot of update transactions during that time, it gets a little trickier. You have more conflicts to resolve potentially, but it is designed to handle the intermittent connectivity, if you will. Other question?
You have I guess the classic problem of when your nodes go offline, you have to keep all the wall logs in order to reapply.
Right. So so right now it's using replication slots between the nodes. So if a node goes offline for an extended period of time, you have to, you as an administrator have to be aware of that. And at some point, if it doesn't come back, you have to part the node and have it rejoin.
Second question actually is how many nodes do you test?
Simon, do you have a number for the?
Well, it's a sort of n squared thing. If you've got, we tested up to 96, but I mean, realistically, you wouldn't want that many. So, Eventually we will support that number of nodes, but that's where we have to introduce cascading. It's not that it's technically impossible, but it would make the architecture so much more complex that the scale of bugs and problems would go up.
Great. All right. Any other question? Oh, there's a question. Yep.
Can you explain in a nutshell how bidirectional replication works and logical replication? Is it somehow related to BDR?
Okay, so the question is, can I explain in a nutshell how bidirectional replication works and logical replication, and is it related to DR?
I mean, are they somehow share the same protocol?
So the logical replication is so the replication is the bidirectional, meaning it replicates in each direction. They're somewhat orthogonal concepts, but the bidirectional meaning it'll replicate in each direction. Logical replication means there's the representation of the data as opposed to the physical format of the data. And the physical data, or the block, if you will, getting transferred over and applied is, as opposed, you may get a string format in the logical replication. Insert into table A this record. The physical replication is, so they're somewhat orthogonal terms. We've implemented this bidirectional replication using logical replication as opposed to physical replication. I believe the physical, I had to think about it a little bit, but I believe doing it in physical replication would be very difficult and probably not what you'd want for these kind of use cases. The physical replication requiring the exact same patch level of Postgres on each end. The question at the back?
Does it also support the load balancing? Like if one node is kind of low,
Yeah, the question is, does it support load balancing between the nodes? We have had people come up with use cases like that where they want to load balance some element of the some element. I mean, there's nothing to prevent you from load balancing. There's two masters. You do need to think about, again, you need to think about a lot of these same issues that I was talking about. Or is that going to generate? It's going to be written twice. Is that going to generate a lot of conflicts? And depending on your use case, and is that okay? Conflicts are fine with them in many cases, but you need to think through. So the answer is yes, you can do that, but you need to think through the larger problem and access patterns in doing so. Do you have a follow-up question?
Yeah. I also each node will have its own different set of sequences. So how does the backup and all take care of it? Do you set up backups on each node separately?
You do want to have a backup in each node. You want to have a DR backup in each node. As we're talking a little bit, the cluster-wide backup and restore is something we're working on for a future release of BDR. Question?
So your conflict resolution, if I understood the talk, was just last right wins?
That's the default behavior.
There's additional wins?
Last update wins, right? So you can install a user-written I'm sorry, so I'm coached to repeat the question. The question is the conflict handling last right wins? And the answer is that is the default behavior. But you could change it, so that first right wins, or that in this case this guy wins, in that case that guy wins. Manager wins over employee or something like that.
There's an API for
You can establish. Yes, you could. Yep. Okay. Great. Welcome. Okay. Any other last question? Yeah. Question.
Is it recommended that that this could be a possible replacement for streaming replication and the need for failover, or is it recommended that we do streaming replication on each master node,
Okay.
and then use those only when
So.
it really fails?
Okay, got it. The question is this a recommended replacement for streaming replication and potentially for handling various failover scenarios? Is that correct? I would say no, it will never completely replace the need for streaming replication. There are some use cases, I do believe, that when you had to use streaming replication before, you may not have to do it now. So, you do not, with logical replication and things like BDR, you don't need to do it. We can talk. I'm at my last 8 seconds, so we can talk after this and say, okay. So I guess that will be my last question. So thanks again very much for coming to my talk. It was wonderful to see all of you and hear what I had to say.